All right, so for today, section 7.1b, we're going to be doing multiplication and division of rational expressions that do not have to be factored. So for today's lesson, we're not going to factor anything, okay? But we are going to be doing a lot of canceling out. So you can see example number one just says simplify, right? We have 5x to the fourth yz squared over 3x cubed y to the seventh w times 6w squared y to the fourth z cubed over 15x to the fourth y squared z to the sixth. Our goal is to simplify this thing as best we can, okay? So the first thing I always tell people is we're not going to worry about the variables so much first. Let's try to fix the numbers as much as we can, okay? Just the main numbers, not the powers, but the big numbers, the coefficients, okay? Now remember, you are allowed to cancel top to bottom. Okay, so I always tell people when you do top to bottom, you're looking up and down like yes, right? Diagonally, yes, okay, but never side to side, okay? So if you kind of look, if you think of the way your face is going to move, side to side cancellation, no, right? Don't do that. Diagonals, yes. Vertical, yes, okay? But never side to side. So can I reduce or can I cancel 5 over 3? Well, I can, right? 5 and 3, nothing goes with it. What about 5 and 15? That's diagonal. Yeah, right? It goes, they do get canceled. So let me go ahead and do that. 5 goes into itself once and into 15 3 times. Okay? What about 3 on the bottom left and the 6 on the top right? Can I reduce those? Yeah, 3 goes into 6 twice, right? So I'm going to make 3 goes into itself once, into 6 twice. Now I'm going to rewrite the problem. This is where I told you guys, I apologize if this is too many steps. I'm just trying my best to not lose anybody. So here we go. Now the 1, see how that 5 became a 1? I'm not going to write it anymore. It's just a 1, so who cares? So x to the fourth y z squared over x cubed y to the seventh w times 2w squared y to the fourth z cubed over 3x to the fourth y squared z to the sixth. Again, this is an extra step you don't really have to do. I'm just doing it to show you guys what we just did. We simplified the numbers. Can 2 and 3 be reduced right here, these two coefficients? No, so we're good with the numbers. Now, let's combine all the letters together. And when we do it, let's put them in alphabetical order so we can organize them as best we can. So what do we have? We have a W, an X, a Y, and a Z. So we'll put the W's first, then the X's next, and then the Y's, and then the Z's. So here we go. We're going to multiply all this stuff together. So the numbers are going to go first. So I'm going to have a 2 and a 3, and I'm going to put a big old line right here. Okay. So 2/3, because 1 times 2, 1 times 3, that's just 2 and 3. All right. W's on top. What W's do I have? W squareds, right? So W squareds on top. What about X's? Well, I don't have any X's on the right side, but on the left side, I have X to the fourth. So let me write down X to the fourth. What about the Y's? Well, I have a Y to the first here and a Y to the fourth over here on top. So that's Y to the first times Y to the fourth. That's Y to the fifth. So Y to the fifth. And then Z's, I have a Z squared on top on the left side and a Z cubed on the right side. So that's Z to the fifth. Okay, now go to the bottom. Do the same thing. Organize your variables. So I have a W on the bottom left, but not on the bottom right side. So it's just going to be a W here. Okay, now let's go to X's. I have an X to the third and an X to the fourth. That's X to the seventh. So X to the seventh. Now, Y's. I have Y to the seventh on the bottom left, Y squared on the bottom right. That's Y to the ninth. That's 9 of them. y to the ninth. And then z's, I only have z to the sixth on the bottom right, so that's it, z to the sixth. All right, now we're going to reduce the letters, okay? Now, well, you're supposed to remember this from, I have no idea when you learned this, but you guys remember that if your power is negative, it belongs in the denominator. You guys remember that? Like if you had x to the negative 2, you're supposed to bring it down. It's 1 over x squared, right? That's what we're going to do right now. We're going to start subtracting powers. And if the answer comes out positive, that means the letter stays up. But if the answer comes out negative, the letter goes down, okay? So for our next step, well, let me start off the next step. So I'm going to put a 2 again. If it looks a little weird with the fraction, don't worry. We can always rewrite it if you really want to. Okay, but here we go. W squared divided by W to the first. So you subtract the powers. W to the first, okay? So 2 minus 1, that's 1. Positive 1, right? So that W to the first stays up on top. What about x to the fourth divided by x to the seventh? If you subtract 4 minus 7, what do we get? Well, 3, but negative, right? Negative 3. 4 minus 7 is negative 3. So that's x to the third. It's on the bottom because the answer was negative. All right. What about y? Y to the fifth divided by y to the ninth. That's y to the fourth, but it's negative, right? 5 minus 9 is negative 4. So that's going to be the news, y to the fourth. And then z to the fifth over z to the sixth. Well, 5 minus 6 is negative 1. So that means the z goes to the bottom, and it's a first power. So it's just z. And here's my answer. I know it looks kind of weird. If you don't like the way it looks, you can always say like, okay, I'm going to put the 2w around the middle, and let me just shorten up the fraction, and there we go. This is what people consider the hard ones compared to the last ones. I mean, at my age now, I don't really consider any of these difficult, but I know I can tell you that I used to like these more than the ones we just did on Friday, because I thought these were easier, because I'm like, well, there's no factoring. How can you call these harder, right? But I can see why, because you can see everything that just goes on. There's so many letters and numbers all over the place, and you got to keep track of it. So my advice to you guys, take your time, be neat, right? Notice how I started off just with the coefficients first. As much as I could, I reduced the coefficients. After I reduced my coefficients right here on the second step, then I said, okay, let's combine everything, but let's make sure my letters are in alphabetical order so that by the time I'm done organizing them, they all are like basically vertically aligned, right? And then I can do my subtractions, okay, my power subtractions. And when I subtract my powers, if my answer comes out positive, the variable stays on top. If my answer comes out negative, it goes down. Okay, whatever the answer was. So if it was a negative 4, it becomes a fourth power in the denominator. If it was a positive 3, it stays in the numerator as a positive 3. Okay, so I'm going to do another one like this, another multiplication, and then we're going to do 2 division ones, then we're done. Okay, but I want to give you guys a good amount of examples just so that you have something to look at when you're doing your own homework. So here's example number 2. Oh, and by the way, if you're wondering if today we're going to do the seating assignment thing, I was going to, but I'm missing enough people, not too many here, but I know I'm missing a lot in 6th, and I don't want them to be like, oh, I wasn't here, I couldn't give you a piece of paper. So I'm going to wait till Wednesday, okay? And then you guys can give me your stuff. I do already have one, I know, but I'll wait till Wednesday, though, to kind of start picking those up. So here's another one. We're going to do simplify. So it's 24 on top, f g to the 7th, h to the 4th over 40 f to the 9th, h to the 5th times 8, whoops. So 8, f to the 6th, g to the 3rd, h to the 3rd over 15, f to the 7th, g to the 9th, h to the 4th. Now these numbers are kind of big in the very front, so it might take us more than one step to simplify everything. Maybe, maybe not. We'll see. Okay? But there you go. Now this is just multiplication. When we do division, there's just one little extra step you got to do. Maybe I don't do 4 examples. Maybe I just do 3, because showing you one of the division ones is the same as these. It's just one quick flip. That's all. So I'm going to have to reduce things, okay? I'm going to start with my numbers first, okay? So I right away notice that 8 and 40 can be reduced kind of nicely because 8 times 5 is 40, okay? So this is what I'm going to do. I'm going to get 8, it becomes a 1, 40 becomes a 5. Now, is there anything in common between 15 and 24? Is there a number that divides both of them? A 15 and a 24? Doesn't 3 divide them both? Right? 8 times 3 is 24. 3 times 5 is 15. So 3 can divide 24 8 times, and 3 can divide 15 5 times. So let me rewrite what I have right now. Now, if you guys don't mind, I'm gonna save us a step right now. Okay, so last time I showed you every step. Let me save us one step. I'm gonna go ahead and multiply the numbers, the green numbers. 8 times 1 and the 5 times 5 on the top and bottom. And then I'm going to organize my letters right now at the same time, okay? So 8 times 1 is 8. And then let's do my letters. So let's see, f times f to the 6th, that's f to the 7th. G to the 7th times g to the 3rd, that's g to the 10th. H to the 4th times h to the 3rd, that's h to the 7th. So notice I organize my numerator completely. On the bottom, 5 times 5, that's 25. In terms of f, I have f to the 9th times f to the 7th, that's f to the 16th. That means there's 16 f's on the bottom. There's no g on the bottom left, but there is one on the bottom right. That's g to the 9th. And then the h's, I have h to the 5th and h to the 4th. That's h to the 9th. So I saved us one step right now, because last time I rewrote the whole problem, but just with the green numbers changed, and that was it. So I'm figuring, well, why don't we multiply the green numbers out and then just fix our letters? Now we're going to start subtracting the powers, okay? So I still have an 8 and I still have a 25, okay, because I'm done with the numbers. 8 over 25 cannot be reduced. But f to the 7th divided by f to the 16th. 7 minus 16 is negative 9. Negative 9. So that makes it f to the 9th on the bottom. Because it was a negative power, it belongs on the bottom. Okay? Then we do g. G to the 10th divided by g to the 9th. 10 minus 9 is positive 1. That means g has a first power, positive power, so it's on top. And then do h. H to the 7th over h to the 9th. 7 minus 9, that's negative 2. By the way, you always subtract top to bottom, okay? So 7 minus 9 is negative 2. That's h squared, and there's my answer. Again, if you want to move the 8g a little bit more to the middle, feel free, but I mean, that's perfectly fine. There's nothing wrong with that. What do you guys think? Is this a little easier than all the factoring we did before? I mean, I think so, but a lot of people, they're like, no, this stuff is hard. Now I'm like, well, if you try to do all of it at one time and you're like just scraping things out, like canceling with the line and everything everywhere, then yeah, it's going to look really messy. So I can see why it would look difficult, but it doesn't have to be. You just just be a little patient, take an extra step here and there, write out your work so you can make sense out of it instead of just rushing through it, right? We don't want to just rush through it because then that's when mistakes happen. So we'll do one more example. It's a division problem. So you might say, well, wait a minute, why just one? We haven't seen one yet. You're going to see it. It requires a flip, and then the rest is basically the same thing we've done. So let me show you what I'm talking about. So this is a division problem. Example number 3. I'm going to put simplify, but in parentheses, I'm going to put division. That way, when you guys look at your notes maybe later, you're going to say like, oh, wait, this one had division. That's what makes it different. The other ones were multiplication. This one starts with division. So here we go. Let's do 21, a to the 4th, b cubed, d to the 6th. I'm sorry. Oh, wait, that's a c. I'm sorry. That's a c to the 6th. A, B, C on top. Over, on the bottom, it's a 4, b squared, c cubed, d to the 5th. That's a c to the 3rd, d to the 5th on the bottom. Divided by, and then the other fraction is 35a to the 4th, b to the 9th, c to the 6th, divided by 3a to the 8th, b to the 3rd, c to the 3rd, d to the 7th. Now, again, I know this says division, but here's the thing. Again, sometime in your past, you had to have heard the following. You don't divide fractions, you multiply by the reciprocal of the second fraction. In other words, I'm going to change this division into a multiplication, and the second fraction, I'm going to flip it over. Okay? I'm going to take its reciprocal. So instead of division of this second fraction here, I'm going to multiply by the reciprocal. I'm going to flip it over. So here we go. First step, rewriting. And this is basically the only thing that's different. So let me go ahead and rewrite the first fraction. 4b squared c cubed d to the 5th times, so notice instead of division, I'm going to put times. And then I'm going to write my other fraction, but flipped. Okay? So times, and here's my fraction bar, 3a to the 8th, b to the 3rd, c to the 3rd, d to the 7th. And on the bottom is going to be 35, a to the 4th, b to the 9th, c to the 6th. So I completely flipped it, okay? I'm going to fix that line really quick. And that's literally the only difference. After this, we do this problem exactly like we did example 1 and example 2. There's no other difference. That's it. Just change the division to a multiplication and flip the second fraction, not the first one, the second one. Okay? So make division into times and then flip the fraction. After that, start to reduce. So let's see. Well, if we look at it, 21 cannot be reduced by 4. 3 can't reduce 35. If we go diagonally, 3 and 4 can't be reduced, but 21 and 35, what number divides 21 and 35? A 7. Yeah, a 7. So 7 divides 21 3 times, and 7 divides 35 5 times. So I'm going to rewrite my problem right now. I'm going to multiply my coefficients, my big numbers. So 3 times 3 on top, 4 times 5 on the bottom. I'm going to multiply those out. And at the same time, I'm going to organize my letters alphabetically, putting them together. Okay? So here we go. 3 times 3 is 9. So let me put that 9 there. I'm going to put a big old fraction bar here. On the bottom, 4 times 5 is 20. So I'm going to put a 20 there. By the way, sometimes students will say like, what if like 9 over 20 could be reduced? Can I reduce that still? Yeah, you can still keep reducing. Okay. But usually if you reduce correctly in the previous step, the result you get after that shouldn't be something you can reduce anymore. But maybe you messed up and you didn't divide enough. You can continue to reduce if possible. All right, let's get our a's together. A to the 4th times a to the 8th on top, that's a to the 12th. I'm going to put a to the 12th power. Next is b. I have b to the 3rd times b to the 3rd, that's b to the 6th. Then c, I have a c to the 6th and a c to the 3rd, that's c to the 9th. And then the variable for d is d to the 7th. Okay, so there you go, top's done. Look at the bottom. My a's, I have an a to the 4th. B to the 11th, because it's b squared times b to the 9th. C to the, what is it? C to the 10th, because c to the 3rd, no, wait. C to the 9th, yeah. C to the 9th. That's a 3rd and a 6th. So that's a 9. And then d to the 5th. Now again, the 9 over 20, it's simplified. I don't have to worry about that. Now I just got to worry about the letters themselves, right? So look at my a's. Well, let me write a fraction again. That way I can write them down instead of just saying it out loud. So 9 over 20. Now, my a's. A to the 12th over a to the 4th. So 12 minus 4 is 8. That's a positive number. That means that a stays on top with a power of 8. Now I move on to b. B to the 6th divided by b to the 11th. Well, 6 minus 11 is negative 5, right? So that's going to go down as a 5th power. Okay, c. What happens with c? It says c to the 9th over c to the 9th. They're identical. What happens? Well, if I subtract 9 minus 9, 0. What's c to the 0? What's anything to the 0 power? It's 1, right? In other words, c to the 9th cancels out, okay? This actually cancels out. They're identical. So since they match, take them out. And then d to the 7th over d to the 5th, 7 minus 5 is 2, a positive 2. That means that the variable d goes up, and that's a power of 2, and I'm done. So notice, guys, when you're doing these problems, if it's multiplication, just do it like normal. If it's a division problem, remember, change the division to a multiplication, like I did right there, first step. The division becomes a multiplication, and the second fraction, just flip it. And then just do the work the way you would have done it anyway. Okay? Yeah. So let me pause this thing. And right now, I'll tell you guys what problems to do.